Audio Jungle. Audio Jungle.
All right. So now here we have first airfoils. Okay. And for the airfoils, what we are going to do, we have to go first for the nomenclature. Today in today's session, we'll go for 2-3 things: airfoil, nomenclature. Okay. Second, we'll talk aerodynamic coefficients and obtaining lift coefficient from pressure coefficient. Yes or no? CL is lift coefficient, and what is the CP? CP is pressure coefficient. It's very important. Okay. So this is the topic we have to cover in this session. Now, first, now we'll see what is the airfoil, and in airfoil, we'll go for the airfoil nomenclature first. So, for the airfoil, what we will do? I will draw one sort of in very basic and very brief explanation about the airfoil. Okay. Like this, focus on it. Or if you see here, it will be like this. Okay. So basically this is what? This is the wing. And wing is always, I told you, it is 3D. So any cross section, the cross sectional shape obtained by the intersection of the wing with the perpendicular plane. Okay, is called an airfoil here. If you check, this is the one wing, one perpendicular plane you have to take, and you have to cut that, intersect that wing, and you may get this shape, this one, or you can say this one, because if you extend this, even though if you extend this like this, so one section you got, and that section is nothing but this one. This is what? Airfoil. So airfoil is basically, it's a 2D. It is also called 2D wing. What it is called? 2D wing. Okay. Always remember. Now, so basically, if you anywhere that wing is there, and anywhere if you cut it by one perpendicular plane, so the cross sectional shape you will obtain by the intersection of the wing with the perpendicular plane called airfoil. So if you cut it by one perpendicular plane, here just say this is the perpendicular plane here, okay. This is suppose a perpendicular plane. If you cut it by this perpendicular plane, the wing if you cut anywhere, so you may get this shape. And this shape if you check, basically this shape will be like this. It is what? It is nothing but airfoil. Understood? This diagram here it is drawn. Now you will go for the nomenclature of this, because there are many terms for the airfoil. So this is very important to know. Okay. Question, sometimes very basic question they are asking. So here I will explain in very short that nomenclature for the wing. So it is nothing but I will draw one airfoil. Okay, here it is. Now for the airfoil there are different terminology. Okay, you just listen, you may understand, because already in your BTech and all you might have seen this, so no issue, you can get it. It's very simple. So check this. Okay, so one circle we have here. Okay, chord, this mean camber line, this is called thickness, per surface, lower surface. All right, say this is nothing but maximum thickness, I can say. So, and why I am teaching all this thing, because if you go for NACA series, so that time you should know the terminology. Okay, this is called location of maximum thickness. Okay, location of maximum thickness. This is called leading edge. This is called, so these all term will come. Okay, in NACA series, all the term will come, leading edge, trailing edge. So that time you should know all the terminology. I know you have gone through this in your BTech session and all, but still I just want to remind you my intention actually. Okay. Leading edge, radius. Okay. Maximum camber, location of maximum camber. All right. Chord line. So these are the nomenclature. Okay. Important I will tell you, rest not required. Like what is the mean camber line, what is the chord line, or what is the camber, and what is the thickness. That basic I will tell you. Rest you can understand what is the location of maximum camber. Once you know maximum camber or camber, what is the location of mean camber, or what is the mean of it. Okay, that if I will tell you, then automatically you will understand. All right. Now, so we'll talk about the mean camber line. Upper and lower surface already I have explained. So, like first, mean camber line. What do you mean by mean camber line? It is the, in short, I'm just saying, it is the locus of points halfway between upper and lower surface as measured measured perpendicular to the mean camber line itself. Simple. I must say, if you talk what is the mean of mean camber line, okay, this is what upper surface, this is what lower surface. All right, exactly mid locus you have to draw. Mean camber line is the locus of points halfway between the upper and lower surface. How you would know? Perpendicular you have to focus, like everywhere wherever you are going to draw, it should be perpendicular. Okay, like this is the perpendicular, this is the perpendicular. Okay, for each points perpendicular the mid of the upper and lower surface, that locus you have to make. Suppose here this is the one point. Okay, the mid of this is this one, mid of this is this one, like this. Midpoint only. Okay, mid of upper and lower surface, the condition it should be perpendicular. If you draw one line, okay, this is called mean camber line. Okay, hope you understood. This is called mean camber line. All right, now what is the leading edge and trailing edge? So if you say this is the mean camber line, so you can say the most forward, what is the most forward of this mean camber line? Most forward will be called as a leading edge. What it is called? Leading edge. I must say leading edge, LE. And most forward and most rearward points, this will be called as a trailing edge. Okay, hope you understood. Then we'll go for the chord line. What is the chord line? That chord line, again very simple, the straight line, the straight line connecting, the straight line connecting the LE, that means leading edge, and trailing edge. Okay, is the chord line of the airfoil. If I draw, okay, this is what leading is, this is what trailing is. So it should be a straight line. From leading edge to trailing edge, it should be a straight line. So this is what called chord line. Okay, this is what chord line. That chord line go away from the surface also. Doesn't matter. Don't think like camber line. It should be inside the surface. I mean between upper and lower surface. But for chord line, no, it is not required. If it is more camber, suppose if it is more camber, then definitely chord line will go out of the surface also. Okay. For example, it is the airfoil is like this. wait, that writing pad is what not having enough space. So okay, suppose this is the airfoil. Now if you go for the leading edge and trailing edge, so sometimes that leading edge and trailing, so this is the surface here, but even though your chord line is what going away from it also, it's possible, nothing to worry. Okay, so diagram should be very clear. I'm not good in doing sketch and all, so please just remove that part and focus on what my statement. All right, diagram you can draw by your own. Anyway, now camber, just like a camber line I have explained, so we have one called camber. Remember, whatever the nomenclature I am giving to you, it is very important once I will go for the NACA series and all. So that time if you know all this terminology, you may understand easily. Okay, what is the camber? So and NACA series question they are asking. Okay, 4 digit, 5 digit, 6 digit they are asking. So the camber is the maximum distance, between mean camber line and the chord line. Okay, measured perpendicular to the chord line. Very simple. But saying suppose this is the airfoil. Okay, this is the airfoil. You know what is the chord line now? Okay, and what is the mean camber line now? You know, this is what leading is, this is what trailing is, most forward and most rearward. Okay, I told you what is the chord line. It's a meeting point of leading and trailing edge, and it's a straight line, or you can say shortest distance between leading and trailing edge called chord line. So shortest distance, it means it must be a straight line. So this is what chord line you can say. Yes or no? This is what chord line. Shortest distance between leading edge and trailing edge. Alright. Now, what is the mean camber line? I told you it's actually mid points of the upper and lower surface. So this is what upper surface and this is what lower surface. Like this. Okay, this is what mean camber line. Yes or no? This is what mean camber line. So you can check here. Even though if this is the chord line, okay, This is the chord line. So somewhere here, this will be the chord mean camber line. Yes or no? This is just say leading edge, and this is say this is trailing edge. So check there. This whatever the perpendicular distance everywhere, it is not same. Somewhere it is maximum. I'm looking here. This is the maximum. Huh? So for as per my point of view, I think this one is the maximum, no? Upper and lower, not upper and lower. This is the mean camber line MCL, mean camber line, and this is the chord line CL. In between the maximum distance is what suppose here as per my concern, okay. And this is the at leading and trailing edge it is minimum, and in between also there are some points, okay. But I'm getting this is the maximum. So the camber, what is the camber? So camber is the maximum distance between MCL, mean camber line. This is the MCL. The whole is MCL. Yes or no? And the chord line CL. CL. So maximum distance, and it should be perpendicular. That measurement should be perpendicular. You got my point? So it should be a perpendicular. You can say this is the maximum here. So this is the maximum distance between the MCL and CL, and it should be measured perpendicular, called camber. Hope you understood. Okay. So now like the camber line and chord line both are different for the cambered airfoil. Based on this, we have types of the airfoil like cambered airfoil or symmetric airfoil. Understood? So in fact, in the airfoil also two types airfoil. What it is called? Cambered airfoil and symmetric airfoil. So how it will be differentiated? Only two things we have. What it is? It is the MCL, mean camber line. Okay, mean cambered line and cambered line, chord line. Sorry. Check for the cambered airfoil. Okay, for the cambered airfoil, the chord line will be, and this is the chord line CL. I must say, this is the CL. This is the trailing edge, and this is what leading is, and this is nothing but CL. Okay, and you say this is the MCL. Okay, this is what MCL. Let me correct this one. This is what MCL means, mean camber line and chord line. Okay, this is what mean camber line, and CL means chord line. Okay, so for camber airfoil, that mean camber line and chord line are totally different, and it is not going to superimpose. But if the chord line and at the same time mean camber line is suppose overlap to each other, this is the say chord line leading edge, this is what trailing edge, and if that mean camber line superimposed, it is superimposed. This is what MCL and this is what CL. If both are superimposed, then what airfoil you may get? It will be symmetric airfoil. Understood? Now I will draw that example for both cambered airfoil and symmetric airfoil. I am just going to draw the example. Check. Many times you have seen this is what cambered airfoil. What it is called? It is cambered airfoil. And what is the symmetric airfoil? Check. This is what symmetric airfoil. For the symmetric airfoil, chord line and mean camber line for symmetric airfoil, mean camber line and chord line will be overlapping to each other, so you may get this, and this is what camber. Okay, symmetric airfoil. I hope it is clear, very clear to you. Right? Now we'll go for next, thickness. In the nomenclature, we had to go for different points, right? Here I explained that leading edge, trailing edge, camber line, maximum camber. Obviously, I told you that the maximum distance between the chord line and mean camber line. All right. Then we'll talk about the thickness, maximum thickness or thickness. So what is the thickness? Check. So thickness basically, if you define, the thickness is the distance it is the distance between the upper surface called US and lower surface, okay, called LS, also measured perpendicular or normal to the chord line. Okay, simple. So I'll show you any airfoil. You can take symmetric or cambered airfoil, doesn't matter now. I'm not good in diagram, but my weakness actually, but anyway. Okay, right. This is upper surface and this is what? Lower surface. So check. This is called thickness. So thickness, you can say this is also thickness. Here also this is thickness. Huh? Everywhere, upper to lower, it should be perpendicular. Okay, that measurement should be perpendicular. It should be perpendicular. Right. Now, somewhere thickness will be less, somewhere it is maximum. So you can say this is what thickness. But somewhere there is the maximum thickness. You just say this is the maximum thickness. You got my point? As I told you, somewhere there is the maximum distance between the upper and lower surface, right? So this is the complete nomenclature of the airfoil. Now all terminology you got it, like okay, so obviously this is what leading edge and this is what trailing edge. So thickness you can measure anywhere, but maximum thickness will be only one. So this is the location of maximum thickness. So now all that, with all the terminology now you are aware. Okay, better I will finish here that NACA series. So at least for 2 marks you will be now perfect, because 2 marks question they are asking from the NACA series. Okay, so better, because now all the terminology you know here. Okay, all the terminology now you know, so it will be better, should finish here that NACA series. So I will write here NACA airfoil. This is the great actually question they are asking from the NACA airfoil. Sometimes 1 mark, sometimes 2 marks. NACA airfoil. So basically, if you say there are 3 types of the NACA airfoil we have, okay, in this, and what it is, if you check, we have a 4 digit, we have 5 digit, and we have 6 digit airfoil. Okay, 4 digit, 5 digit, and 6 digit we have. So all one by one we'll see, and many times question they have asked. Okay, and here you may get, because one time they had said what is the NACA series for the symmetric airfoil. So now all the terminology you know, now it is very easy to you to understand that when it will be symmetry, because just now I have explained you what is the symmetric airfoil and what is the cambered airfoil. Okay, so with the all explanation what we have done here, now easily you can connect that NACA, all like 4, 5, 6, whatever it is, easily you can connect it, because terminology now you are aware with it. Okay, so we can write here, this is what NACA 4 digit airfoils. Five digit airfoils, and next one is called 6 series NACA airfoil. Okay, all right. So there are some specification for all the types. For 4 digit there is the one specification. Similarly for the 5 digit we have one specification. Then for 6 digit we have one specification. So for all type of the airfoil we have a special significance. Okay, there is a significant uh, like parameters for all 4 digit, 5 digit and 6 series, or 6 digit also you can call it. Fine. Now, so one by one we'll see. First one is NACA. 4 digit airfoil. Okay. By the word only you can understand 4 digit means what? Whatever the numbers will be, it will be like 4 numbers. Yes or no? That 4 number can be anything. It can be anything, and there is the special significance of each numbers here. Like suppose one number is what at one position, second number is what at another at second position there is the another number, third position also there is the one number. So there is the special meaning of it. Okay, there is the special meaning of it. So one by one we'll see. All right. This is the one example I am writing here, NACA 2412 airfoil. So now whatever the length we will write, maybe location of maximum thickness, location of maximum camber. So it will be in percentage of chord. So this is the airfoil now. Okay. This is the airfoil, and you say this is the C, chord length. So whatever the location we'll write in terms of C, that is the chord length. So the first digit here, what we have, the first digit will indicate maximum camber. Okay, the first digit indicates the maximum camber in percentage chord. I will write maximum camber in percentage chord. Okay, the second number, you just listen carefully, it's very easy only. The second number, what is this? The second number, the second digit indicates position of maximum camber in tenths of chord length. Okay, and what is the last 2 digit? Okay, so last 2 digit, it's a combined. What is the last 2 digits? It's a location of maximum thickness. Okay, what is the last 2 digits? It's a maximum thickness, you can say, not location. For 5 digit you may get that location also. So maximum thickness. Maximum thickness. Okay, and that maximum thickness okay, this will also be in the terms of maximum thickness. It will also be is the percentage chord. Okay, because you have to write in terms of the percentage of chord. So like middle one, it was in tenth of chord, but this is the maximum thickness also you have to write in percentage of chord. Now we'll calculate it, so it will be more clear to you. Check, we are going to calculate what they are saying. They are saying maximum camber in percentage chord. What? That first digit. Yes or no? So what is the first digit we have? We have it's a 2412. So if you write 2412, first digit 2 will be the maximum camber in percentage. So 2 we have, and it is in percentage, so multiply by divide by 100. Percentage of what? Chord length C. So you what you may get? You may get 0.02 C. Remember it. Okay. This is the percentage of chord, 0.02 C. This is the maximum camber. Yes or no? What is the second? Second is the position of maximum camber, means position, or you can say it's a location, and everything I have explained what is the location or position of maximum camber. So everything you are measuring, all the distance you are measuring from the leading edge, always remember. So but it is in tenth of chord length. So position of maximum camber, what it is? 4, second digit. So 4 divided by 10th. 10th means divide by 10 of what? Of chord length. So what you may get? You may get 0.4 C. Yes or no? 0.4 C. This is the position of maximum camber. Third one, last two digit, 1, 2. It is the maximum thickness in percentage of chord. Percentage of chord means divide by 100 into C. 0.12 C. So simply one airfoil they will give to you. Nowadays the question they are asking in multiple select. Okay, for one series of the airfoil they will give, and many things they will ask. They will ask like, okay, what is the maximum camber, what is the position of maximum camber, or what is the maximum thickness, everything they will ask to you. So that time you need to know each and every point, so then you may answer it. So sometimes it's a confusing thing. Which one is the percentage of chord or which one is the tenth of chord, that may jumble in examination. So that's the reason I told you. In this way, if you go, okay, and just make a photographic memory. Photographic memory in the sense, few things you need to click that photo in your mind. That image should be there. If I have shown like this, then you should remind it. I mean, that photograph of this should be in your mind. Like, oh, you have to imagine, okay, sir had drawn 4 digit. So first digit it was upper one, second but middle one, and last two digit it was down one. So down one was 100%, first one was 100%, and middle one was 10%. Like that you have to make a photographic memory, what I can say. Yes or no? So it's a maximum thickness. So this is nothing but maximum thickness, and by definition also I explain you what is the maximum thickness, because I told you thickness they are it's a distance between upper and lower, but maximum thickness it's a one special point where you may get maximum distance between upper and lower surface. Thickness there are multiple points, but maximum thickness will be one point only. Hope you got my point. Yes or no? So you got the maximum camber, percentage of chord, okay, and how to reconnect it. You always remember, for the 4 digit you have to go in this way. 4 digit it's like you can take a concept in this way, so it will be better to you to understand. You have to write for 4 digit, you have to write 1 plus 1 plus 2. What is the mean of it? For 4 digit NACA series you have to take one digit separately, another digit separately, and last 2 digit you have to take combined. First digit it will be percentage of chord, so you can say it's C by 100. Last 2 digit it will be C by 100, percentage of chord, and middle one it will be C by 10. So you can say 100 plus 10 plus 100. You make some sort of like photographic memory. You can connect in this way. Okay, one first was it was like 100, middle was 10, and last was 100. What is the mean of 10 and 100? You should know. Otherwise, how you will answer? So this is the things you need to remember in this way. Okay, done. Now we'll go for the 5 digit. Yes or no? 5 digit. We'll go for the, okay, at the same time, if I, another example if I will give, so you can answer, but one very special, if I, this is the special case, okay, this is asked in your exam, special case. If I 4 digit only, if I give NACA, I can give 0012 for the same airfoil, for the same airfoil. Now you directly you can answer for this. This is what the maximum camber, and it was C by 100 into first digit is 0, so what is that? 0. Second, location of maximum camber, what it was? It was C by 10 into that digit is 0, again you got 0. Last, it was maximum thickness, what was that digit? 12 into 100, C by 100, so you may get 0.1. So thickness you got, but there is no camberness. Obviously, if there is no camberness, so location also will be 0. If there is no camberness, means maximum camber will be 0. If there is maximum camber 0, it means there is no camberness. So obviously location will also be 0. What is the mean of it? What is the mean of it? Its meaning, for this airfoil there is only one thickness. There is no camber. If there is no camber, it means it's not. How many types of the airfoil? Basically, 2 types. What is that? Camber airfoil and symmetric airfoil. If there is no camberness in the airfoil, it means it is not a cambered airfoil. It means what is the type of airfoil? It's a symmetric airfoil. It is asked in examination also, right? Yes. So it's a symmetric foil. This is asked in your exam. Okay. Check, there is no camberness, only maximum thickness. Where is the maximum thickness? Check the diagram and you can draw. As per your diagram, you make one maximum thickness. I am just getting this is the maximum thickness. Or here you can say this is the maximum thickness. Maximum thickness. So you can say T max. Yes or no? So it's a symmetric airfoil. This is asked in exam also. Remember it. Right? We'll go for the next, which is called 5 digit. Now we'll go fast because 4 digit we understood, so 5 digit we can easily understand. Okay. Check. We have a 5 digit. Five-digit airfoil or 5 series. Again, how many points numbers will be there? 5 numbers. And similarly, like previous, there is the special significance of all numbers here. Yes or no? We'll see, we'll write one example so it will be more clear to you. I am writing NACA 23012 airfoil. Okay. Now check. So again one by one we'll write it. The first digit when multiplied by 3 by 2 gives design lift coefficient in 10th. Okay. So it will be a lift coefficient. Okay. First digit what will give? It will give lift coefficient. Means CL value it will give. How it will give? You will take 2 by 3 of what? Of that digit, first digit. What is the first digit? It is 2. So 2 into 2 by 3, sorry, 3 by 2, not 2 by 3, sorry, made it. I made mistake, let me correct it. It's a 3 by 2, no? Let me write here, otherwise it may, here. You have to multiply by 3 by 2. Okay, so better. 3 by 2 and first digit into 3 by 2 of 10th. Okay, leap coefficient in 10th. So no need, because it's a leap coefficient, it's not a like related with the chord length, it's not related with the coordinate or chord length. Okay, so what you will write? You will write first digit as a leap coefficient. So it's a in 10th. In 10th means you just multiply by 1 by 10. Okay, leap coefficient. Okay, or let me write the statement, otherwise you may get, now you will understand but later on you may get confused. Yes, design leap coefficient, it's a design leap coefficient. Let me write here each and every, it will not take 5-10 minutes, better I will complete the whole session. In hurry if I will give, then not now but after 10 days you may get confused. First digit, first digit when multiplied by 3 by 2 gives design leap coefficient in 10th. Okay, second, next 2 digit, I must say this combined one, next 2 digit, next 2 digit when when divide when divided when divided by 2 gives location of maximum camber, location of maximum camber in percentage of chord. Okay, percentage of chord, and the last 2 digits gives the maximum thickness in 100 of chord or percentage of chord minimum. Okay, it will give maximum thickness in percentage of chord. Now we'll check the calculation. What calculation will do? See, first digit will give the leap coefficient once you will multiply it by 3 by 2, and that leap coefficient will be in 10th. So first digit is 2 multiplied by 3 by 2, it is in 10th means 1 by 10. What you may get check? You may get 0.3. Alright, this is the mean of first digit. Second 2 digit, once you go for it, So second two digit is what? 30 divided by 2. So 1 by 2. It will give the location of maximum camber in percentage. Percentage of chord means C by 100. How much you may get? Check. I think it is 0.15. Yes or no? Check it. 0.15. For the third one, maximum thickness is percentage chord. So we have last two digit, it is 12 into C by 100. It means 0.12. This is the mean of it. All right. So what is the conclusion of the 5 digit? The conclusion of the 5 digit is what? If you check, it's a very interesting actually. The combination, if you check, it's like 1 plus 2 and 2 means first digit single you have to take, second and third digit combined 2 digit you have to take, and again 2 digit you have to take. First digit you have to take, and what you may get? You may get CL. How you may get? You just multiply it by 3 by 2. Yes or no? And it is nothing but P by 10. Second, it will give the location of maximum camber, so it is percentage of chord, and this is also percentage of chord, which is nothing but maximum thickness. So you make your mind, just take a photographic memory of it, and then just once you see, automatically you will understand. It's not a difficult thing. Okay, we'll go for the last. All right, we'll go for the last, which is nothing but 6 digit. So it's a 6 digit NACA airfoils. It is also called it is also called, this is asked in GATE also, laminar flow airfoils. Make a special note, all 6 series airfoils called as laminar flow airfoil. Okay, you should remember this. Now in short I will give the name NACA 6 series airfoil. What I will write? I will write example. NACA 65-218. Okay. All right. NACA 65218. The 6 series is the 65218 airfoil. I mean that series will be given like this. Okay. So in short we'll go for it. The first one will give the, it will give the location of minimum pressure. Okay, in 10th. Wait, it's my mistake. Wait, I'm in hurry, I think. Wait, let me correct. I'm in hurry. First I have to start from first one. and this is right. First will indicates what it will indicate. It indicates series. Check, this is the 6 series, hence 6 it is given. So 6 is the indication of the 6 series, okay, or NACA 6 digit or 6 series you can say, okay. If it is confusing word 6 digit, you give the name 6 series, okay, because digit means 6 digit you may search in examination. So better I will change the word, it's a 6 series. Now it is fine. So first word, first number will indicate you the series. So it is given check 6, hence it is called 6 series airfoil. Then second, it will indicate the minimum pressure or location of minimum pressure in 10th, okay. Then we'll go for the third one, which is nothing but what is the third? This 2 indicates design lift coefficient, okay, in 10th, and last 2 digit indicates the thickness, maximum thickness in percentage of chord. Yes or no? So remember, whatever the value like location, if you are writing, so location always from the leading edge, always remember, okay, there should not be any confusion, okay. Now if you check 6 series, it is clear now. What is the location of the pressure? So it is the location of minimum pressure in 10th. Yes or no? Location of minimum pressure in 10th. So what is that? It is 5. So I can say 5 in 10th location. So C by 10, you may get 0.5 C. This is the location of, I must say, distance x p, location of pressure or minimum pressure, okay. Design of lift coefficients, okay, it is directly in 10th. So design of lift coefficient, which is nothing but CL, what is the value? 2 into 1/10, because it's not depending on the chord length, so it is 0.2 only. Don't write 0.2 C, it is not with respect to C, it's not with respect to chord, it's the value lift coefficient 0.2 C, 0.2, 2 into 1 by 10. And the last one is nothing but maximum thickness, okay, it's not location of maximum thickness, it's only maximum thickness, which is nothing but T max. So last 2 digits.